Hey everybody, well it's time to show another lifter version. This particular lifter version I've been working on for a while. It performs pretty much like all the rest of the lifters, but it does use a different type of method to secure the position of the carriage whenever it's tilted along the vertical support. It's based upon something you've seen before. I've used this method of a chain and a cable going through a chain to slow or to control the drop speed of the carriage whenever I was showing you the lifter with the pump jacks. So I decided to take this a little bit further and use the chain and the cable going through the chain as a method to support the carriage. You know that whenever the chain is collapsed, the cable goes through the chain quite easily. But whenever the cable is, whenever the chain is extended, trying to pull the cable through the chain, it locks it in place. So that's what we're using over here on this particular lifter. On each side of the carriage, along the vertical support here, these projections and these projections here support the carriage whenever it's tilted back and forth by first pulling the cable up through a collapsed chain whenever it's tilted, and then whenever the carriage tries to come back down, it extends the chain and it locks the fulcrum position on the vertical support in place. And so successive tilts back and forth allows me to position the carriage and tilt it up the vertical support. But this is really a very cheap way of providing a method of supporting the carriage. It does have some drawbacks. There's some friction through here, even though the cable, the chain is collapsed. There's still some friction, and on the recovery time there's some distance that is lost in the tilt whenever the carriage repositions itself and applies a pull on this cable. So I've minimized that somewhat by putting multiple chains on each side. In fact, I've got two chains on each side, and I've shortened the length of the chain so that there's not as much of a distance that is pulled whenever the chain is extended. There's a sort of a science behind it. I haven't got it all worked out. I'm sure there's an optimal position of number of links, to chain size, to the weight, to the recovery time. One of the nice things about this is that each one of these pairs of chains supports a portion of the weight of the carriage. So if you wanted to add more weight to the carriage, then you could add more chains out at the bottom here. I'll show you that in a minute. But you could add multiple chains, as many as you needed to support whatever weight or whatever size of carriage that you're dealing with. So it's easily expandable. Let me show you what that looks like. As you can see here, I have a pair of chains, and I have a weight which pulls the chain down and helps to keep it in a locked position whenever this lever arm is pulled down by the weight. But whenever the carriage is tilted, it tries to pull this end of the cable up through the chains, and the chains give a little and they collapse, and it allows the carriage to tilt. As soon as the carriage tilts, these weights pull the lever arm down and allows the cable to lock into position. So at the bottom here I have two pulleys. On one side of the pulley, on this side of the pulley, the cable goes up and connects to the bottom of the carriage. On the other side, on the back side of the pulley, it goes up and over pulleys that are up inside the vertical support beam across the top here, this projection. And comes back down and is attached to the top side of the carriage here. So when this carriage is tilted, this slackens and the bottom pulls the cable up through the chains, and then when the carriage tries to go back down, this side is tightened and it pulls the cable through the bottom of the pair of chains there, locking it in place, and it prevents the carriage then from slipping and holds it in place at that fulcrum position. It's really simple. Once you understand the mechanics of the chain and the cable going through the chain, it's really easy to work with. So I'll show you what it looks like whenever I'm tilting it up, and it only goes up about 2 feet, so it won't take but just a few seconds or so to tilt it up, and I'll show you what that does. So there we go, that didn't take much to lift. I know it looks complicated with all these cables, but once you understand what they do and what their purpose is, it really breaks down to just a few assemblies. These 4 cables are these 2 cables, which looks like 4 cables, but one side is very tight because that's supporting the carriage. The other side is a little loose because there's no weight or there's no pull on it on these cables because they go down through. So the active side is the inside And then these cables here, they're used to pull the drop cable tight around this particular they're used to pull the drop cable tight around this winch. And like I said, I've got the drop cable in a 2-to-1 ratio, which reduces the amount of torque on the output gear system. So let me show you what this looks like when it comes down. Very easy to release. It's probably easier than any of the rest of them that I've ever made. So the generator that I'm using is the generator that came out of a gravity light. I've taken my gravity light apart to get to its insides, and as you can see, that's a generator is attached to a planetary gear system here. And with a 3D printer, I've been able to print out sprockets and other gears that are related to this. I've created an adapter for the gravity light, which normally uses a ball chain. And now that with this adapter on there, the generator can use the planetary gear system there can use a number 25 chain. But you can see these satellite lights that come with the gravity light are putting out a steady glow. And the planetary gear is the same as the one that I have here that I've modeled from that one. This one I've modified though to be able to use the number 25 chain sprocket. It's got a little key on it, so I can put it on there. It also has, I also created a ball chain sprocket, and this turned out really well. You can see it keeps spinning after I let go, after I put a spin on it, so it's got pretty good efficiency. There's the rim gear, and the planetary gears are compound gears. There's 3 of them. So these compound gears are turned, of course, by the rim gear, which goes to the sun gear. The sun gear is a compound gear, and it goes to the output gear that would turn the generator. So I was really pleased with this. It's not quite as efficient as the one that came out of the gravity light. The plastic is certainly different, and then of course when I use this ball chain is a lot lighter than the number 25 metal chain, so I get a little bit better results from that. But with a 3D printer, you can print out all sorts of gear mechanisms, different sizes and shapes, and so it looks like for the time being my output problems have at least been solved. So I can go back to building lifters without worrying about how I'm going to extract the energy from it. Because definitely you want to do that, because once you get about 150 or 300 pounds tilted up at vertical support, you have to get it back down again. And so one of the simplest ways, other than taking the blocks out of the carriage, is to bleed off the stored energy through a gear system. So that is one of the latest lifters. It works really well. It's really easy to expand, and like I said, you can build it out of parts that you get from your local hardware store. So I hope you enjoyed that, and build more lifters. Thanks a lot.